Hello everyone. In this video we'll learn logarithms. Let us define logarithms. Say we have three quantities a, b and c. And the relation between these three quantities is a is equals to b to the power of c. Here b to the power of c, is it in the form of index, right? Which we have discussed in previous sessions. So I want to find out this c value. In order to obtain this c value, we have to use logarithms. So therefore, c is nothing but logarithm of a to the base b. So from this definition, I can say that logarithms are inverse operation to indices. Fine. Here a is called number and b is known as base. So once we raise this b to the power c, we are obtaining the original number. Let us consider one example. So we can define that logarithm of a number a to the base b will be equals to c. That is, log a to the base b is equals to c. Let's take one example. If it is 9 square, that is equals to, as you know that it is 81. Or else we can represent it as 2 is equals to logarithm of 81 to the base 9. So if I want to get 81, what I have to do? I have to raise this base to the power 2. So we can define logarithm of a number as logarithm of a number to the given base is the index or the power to which the base must be raised to obtain the original number. That means in order to obtain 81, we are raising 9 to the power 2, right? Let's consider one more example. If it is 10 cube, that is nothing but 1000, right? So 3 is nothing but logarithm of 1000 to the base 10, right? 10 cube gives us 1000. This is the original number. So from this definition, we can say that a is equals to b to the power of c. Logarithm of a to the base b is equals to c. These two are called transformations, right? As we are able to obtain one from the another. Now let's see, logarithms can be of two types based on the base. So if logarithm base is 10, then these are called common logarithms. One more type of logarithms are logarithms with base e, and here these are called natural logarithms. Next comes the question, what is e? E value is equals to 2.33. It's approximate. Now let us solve some illustrations in order to understand this logarithm definition clearly. Based on the definition of logarithms, let's look into some simple illustrations. So if it is 2 to the power of 4, what's its value? It's nothing but 16, right? So this is in the form of index. Now I want to represent this in terms of logarithms. So from definition of logarithm, we can write it as 4 is equals to logarithm of 16 to the base 2, right? So that means when we raise 2 to the power of 4, we are obtaining 16, right? Now let's look into one more illustration based on negative exponent. Let's take 3 to the power of minus 3. As you know that its value is 1 by 27. Now I want to find out logarithm of 1 by 27 to the base 3. Then its value will be logarithm of 1 by 27 to the base 3 is equals to minus 3, right? That means when we raise 3 to the minus 3, we are obtaining 1 by 27, right? Now, let's see one more illustration where we have to find out the base value. It's given that logarithm of root 2 to the base a is equals to 1 by 8. Then what is the value of a? In order to obtain this, let's use the transformation. That means root 2 is equals to a to the power of 1 by 8, right? Or else we can write it as 2 is root 2 to the power 8 is equals to a. As you know that root 2 is nothing but power 1 by 2. So that means 2 to the power of 8 into 1 by 2 is equals to a. Here we can cancel 2 with 8. So it is 2 to the power of 4. Therefore, a is equals to 16. Right? Let's look into some more illustrations. The first question is logarithm of 128 to the base root 2 is equal to. In order to solve this question, let us consider the given question as x. That is, let x is equals to logarithm of 128 to the base root 2. Now what we can do? We can raise root 2 to the power x. Let's do that. So root 2 to the power x is equals to 128. Or else we can write it as 2 to the power of x by 2 is equals to 128. If you observe here on the left hand side we have 2 to the power x by 2. If you represent 128 in terms of two powers, then from the laws of indices we can compare the powers, right? So let's do that. So as you know that 2 to the power of 5 is 32, correct? 2 to the power of 6 is 64 and 2 to the power of 7 is 128. So let us substitute that. So 2 to the power of x by 2 is equals to 2 to the power of 7. Now we can compare the powers as the bases are same. Therefore, x by 2 is equals to 7, which implies x is equals to 7 into 2, it's 14, right? So the answer is D, right? Let us solve the second illustration. It's given that log of x plus 1 to the base root 3 is equals to 2, then the value of x. In order to obtain the x value, let us use transformations. That is, logarithm of x plus 1 to the base root 3 is equals to 2, or we can write it as x plus 1 is equals to root 3 square. As you know that we can cancel out square and square root. Therefore, x plus 1 is equals to 3, or x is equals to 3 minus 1, that is equals to 2, right? So the answer is C. Let us solve the third illustration. Here the question looks confusing, but it's easy to solve from the transformations. So solution. First we'll write the question, that is log 4, log 3, log x to the base 2, this is equals to 0. From transformations, we can raise this 4 to the power 0, right? So that is nothing but any number to the power 0 is always 1. So we can write it as 1 on the right hand side. So log 3 logarithm of x to the base 2 is equals to 1. Again we can raise 3 to the power 1. 3 to the power of 1 is 3. So let us substitute that. So logarithm of x to the base 2 is equals to 3. 3 to the power 1. Next is x is equals to, we can raise 2 to the power 3. That is 2 cube. Its value is 8. Therefore, x value is 8. Right? Let us solve the fourth one. If log x to the base 10 is equals to 4, then the value of x is. From previous examples, we can solve this question very easily, right? So logarithm of x to the base 10 is equals to 4. In order to get x value, what we have to do? We have to raise 10 to the power 4. That is 10 to the power 4, or we can write it as 10,000, right? So its value is C, right? In next session, we'll discuss properties of logarithms. Please feel free to provide your questions or comments in comment section. Thank you for listening and have a good day.